is we are going to be talking about about some elementary programming concepts, and in this, your book starts right around page 27, 28. Let me get you the exact page here. It's actually page 32. Talks a little bit about learning some basic programming concepts. And so for this, it walks you through a basic creation of a program that allows you to calculate the area of a circle. And we know that the area of the circle is calculated by pi times the radius squared, so pi r squared. You've heard that before. And the best way to do this is to you can always do just do a you can create a variable, and what a variable is a way for us to store information into a reserved memory location. Now notice, interestingly, if you've had other programming languages, that Python does not require a data type whenever you declare a variable. When I say a data type, it might be, for example, if you had Java in the past, you might have to type in int to declare it as as type integer, or you might declare it as a string in other languages. But in Python, you don't have to do that. It is not strongly typed, which what it means is that Python is able to deduce and determine the data type whenever it's read by the Python interpreter. And so what we can do with variables, the neat thing about variables is that we can declare them on the fly, but the best thing to do is to declare variables at the beginning of a program, because that way, if you ever need to change the value of a variable, you know that all your variables are at the very top, and you can just change the value of those variables at the top instead of going through the code, and then you can reference them later, and your logic stays the same. And so, for example, say you wanted at some point you wanted to change the value of radius to 19. Okay, you can do it manually here, but if we hadn't created this particular variable, then we would have to type in 19 times 19 times pi to get to that value. Well, with a variable, it allows us to allocate a specific piece of memory for this value. And so say right now we're looking to create a circle and to determine the area of the circle, saying that the radius is 20, and we know that the value of pi is approximately 3.14159. And so the way for us to calculate that is that we're going to declare a new variable called area, okay? And then we'll say it's equal to the radius times, and the times is asterisk, which is shift 8. Radius times radius times pi. So what it's going to do is it's going to look for the value of radius, which is be 20, the other value of radius, which is 20, times the value of pi, which is 3.14159. And then we have a third line, or a fourth line in this, which actually does which actually prints out the calculation, where we say the area for the circle of the radius, comma, and then it tells the program, the interpreter, to print out the value of the radius, comma, and then print out the area. So what does this look like when we run it? So let's do that, and let's run the module. And here we are in idle. So this is the value of this program. So so it says when we ran it, it said the area for the circle of radius 20 is 1256.636. Very easy program to do. We can change the value. Since it's a variable, we can change the value to 5 or 4, and we can save it and run it, and then it printed out for us very neat and clean. And instead of doing you know, this times pi, you know, then what we have, all we have to do is it'll give us the same value, but you know, when we run it, but we've had to change two things here when all we really needed is a variable. So variables, among many other things, is they save you time when you are programming. Now, you're not always going to want to hard code the values of variables into a program. Sometimes you're going to want to get input from the end user, and so to do that, we use the input function in order to grab that information. And so here's a new version of our program, and where we declare that radius is equal to, and this is the eval function, okay? And inside that eval function, we've got open and closed parentheses, and so it wants us to evaluate what is inside this this particular piece of code. It says input, enter a value for the radius. So what's going to happen is whenever we run it, it's going to prompt the user for a value, and whatever the user puts in as the value for that radius, it's going to assign that value to radius. And so again, we've created pi as 3.14159, said that the area is radius times pi, and then we're going to print that out. So say let's try running this. And over here, we can see it's prompting us to enter a value for the radius. Well, let's enter the number 4 and see what happens. Okay, when we enter the number 4, then it allows us, it runs the program completely, and we're able to do exactly what we need to do here. So in this case, we can use that input to be able to run our calculation. And this is a lot of times what you do in software is you gather input from the end user, you do a calculation, and then you spit out the output to the end user. So very, very helpful. Now you can do multiple inputs. You don't have to just do one input. And so your book gives you an example of learning how to get multiple inputs. So say, for example, we have three numbers, and say let's say we have our managers of a basketball team, and our top 3 scorers. We want to know what the average scoring, what the scoring average is for the top 3 scorers on our team. Okay, and so we've dedicated 3 different lines of code to prompt the end user 3 times. Okay, so enter the first number, the second number, and the third number. Okay, and so it's going to, whatever we put into these values, when we run the code, it's going to prompt the end user to enter the correct number. And then we do a little bit of math. We declare a new variable called average, and we say that the average is equal to the sum of number 1, 2, and 3 in parentheses divided by 3, and that's how we take an average. We sum up the total of the 3 divided by 3, because we have 3 numbers, and then we print out the average of all 3 numbers. Okay, so let's see how this works. All right, so let's pretend that player 1 scored 21 points. Let's pretend that player 2 scored 10 points. And maybe player 3 only scored 3 points. Okay, once I press enter, it's going to go to the next line of code, which does our math for us, and then after that, it's going to print out the resultant of this particular equation. It says the average of all 3 numbers is 11.3, and so, but if we add it up and do the middle math, we notice that it does add up, and it is completely correct. So this is how you can enter multiple inputs and assign them to variables, as your book talks about. Your book also continues to talk a little bit about some things and some rules about variables. One interesting thing that you can find helpful when you're programming is that sometimes you'll have a really, really long calculation that kind of runs over to the end of the line, but you can use the line continuation symbol, and what it will do is it will continue the code on this line and whatever's on the next line, it'll continue continue it and include it in the previous line. So use that backslash to be able to do that. So let's run that just so you can see. And so our answer will be 3, 6, 10, 15, 21. So let's run it. And we see, yes, that it is including that +6 when we try to print out the sum. So just a handy thing that is really helpful whenever you try to program, because sometimes your line statements can get really, really long, and that's really helpful for you. Now, the book talks a little bit about identifiers. There are several different types of identifiers. One of them is called a variable, and we've talked a little bit about variables so far, but variables have rules in Pythons. And so a couple of things for you to know and to keep in mind is that in Python, all your variables must start with a letter or an underscore. Okay, you can never start them with a number. Also, identifiers cannot be a reserved word, such as import. Okay, they can be of any length, and also the case doesn't matter. So it can be uppercase, lowercase. It really doesn't matter. The Python interpreter is able to see all of them no matter how you refer to them. One thing that as a programmer that is a best practice, because if other programmers are looking at your code, it's easier for them to identify variables by using what we call camel case. And what camel case is, you kind of think of a regular camel, they have humps. And so in the middle of your variables, especially if they are multiple word variables, you'll have the first word lowercase and the second and third words are all uppercase. And so say we had a multi-word variable called number of students. To put it in camel case, N would be lowercase, O would be uppercase, and S would be uppercase. And so that allows us to kind of apply a common programming convention called camel case. Another thing that your book talks about is that whenever we go to assign a value to a variable, that the variable name comes first and we assign the value to it second. So we would say x equals 1, not 1 equals x. You'll get a syntax error if you do 1 equals x. So always the variable comes first and the assignment value is second. Another rule with variables is that you must declare them first before trying to modify, and we'll talk a little bit more later in the course when we talk about scope, the scope of a variable. But for example, you can't do something. You can't declare a variable called and then try to modify it. So it's really important to make certain that you do it in that way. Also, you can use variables to represent mathematical expressions, and so I have an example here that does that. And so we create. This is the program that we start out with at the beginning of the class, where we declare radius is equal to 20, and then normally pi is 3.14.159, but we can approximate pi by dividing 22 by 7, and that'll give us an approximate value for pi. It's not exact, but it's close. But you notice that in calculating pi that we are doing a mathematical expression. So you can assign mathematical expressions into a variable, because if we run this, it's going to multiply radius times the value of pi, and it'll print it out for us. So let's run that and let's see what it looks like. Okay, and so again, it's close. It's 1257. We noticed when we ran it before that it's a little bit different. So it's close. 22 divided by 7 is close. But just so you know that the main thing that you should know is that you can assign multiple mathematical expressions to variables, and it will run them on the fly. Now, we do have variables, but we have another type of operator called a constant. And what a constant is a value that will not change while the program runs. And let's look at an example of a constant. This constant, so we know that pi is a mathematical constant. It doesn't change, and it will never never change. And so what you might want to do is you might want to denote your constants with all capital letters. So if it's something that never changes, such as, for example, the tax, the value of tax, it might always be 6%, and so you assign that to a constant named 0.06, and that way you can, it's never going to change. And so constants always are values that don't change while the program's running, and you denote them with all caps, okay? And so if we run them with all caps, that just helps other programmers to know exactly what you're doing. So let's run this, save it and run it, and you'll notice that once again we have the correct value of this because we've declared this constant named pi. Okay. All right, let's continue on with some other things from your book. So your book continues to talk about this thing called numeric types. And in Python, if you've studied Java, you know that there are 4 or 5 different types of numeric types. But in Python, there are only 2, and they are integers and floating points. And what our integers are, very simply, is whole numbers. It's 1, 2, 3, 4, 5, 6, 7, all the way up to million and beyond. But they are integers. They're whole numbers. Floating points, by contrast, are fractional or having decimal points, and that's what a floating point type of numeric type is in Python. We also have multiple types of operators to do mathematical calculations. We've seen that the plus sign is for addition, the minus sign is for subtraction. We use the asterisk for multiplication. We use the single divided by for float division, and we use the double / for integer division. We'll look at an example of that here in a second. We have 2 asterisks for exponents or powers, and then a percentage sign for remainder. So let's look at 4 different examples of this. So the first thing we do is, this first example is floating point division. We're going to have in this we'll have a decimal resultant if we divide 22 by 7. The second one, we divide 22 by 7, but because we use 2 forward slashes, it's going to be integer division. This is 3 to the second power because we've used two asterisks, and so it's going to raise 3 to the second power. The value should be 9, and then print 22 remainder modulus or remainder 7. So that's an example of the remainder that you get when you divide 22 by 7, which we know that 22 divided by 7 is going to be 3 with remainder 1, so the answer for this fourth one should be 1. So let's run it and let's see the different types of outputs whenever we run it. Okay, so the very first line is we get a floating point. Okay, so floating point division. Second one is integer division. When we divide 22 by 7 in integer division, the answer is 3. And then whenever we raise 3 to the second power, we get 9. And then whenever we divide 22 by 7, the remainder is 1. And so all of these are correct, and these are examples that you'll be using throughout this course. So you will definitely need to memorize these particular concepts. The next thing that your book talks about is order of operations, and we always have a handy acronym that we need to remember, not only in math but also in programming, and that's the concept of PEMDAS. And what this is an acronym so that we can remember the order of operation whenever we are programming. And what this acronym stands for is that we always evaluate parentheses first, and then we evaluate exponents, and then after that multiplication and division, and finally after that addition and subtraction. So this is the order of operations, and so let me give you an example. So in example 1, we declare a variable called mynum, and you notice that it is in camel case. We have two words there. So the first word is lowercase and the second word is uppercase, and there are parentheses around this. So because there are parentheses here, there are this will be evaluated first. And so basically what this is going to be is it's going to be the equivalent of 10 divided by 4. Now over here, we don't have parentheses for my num2, and that's going to be 5 plus 5 divided by 4, because division always takes precedence over addition. We will be evaluating 5/4 first and then adding that value to the number 5. And so let's see what happens whenever we run it. And we notice that in the first case, that the parentheses give us a very, very different value than when we take the parentheses out, 2.5 versus 6.25. So it's really important if you want to avoid logical errors in your programs to pay attention to the syntax whenever you are making calculations. Always remember, PEMDAS is that acronym: parentheses, exponents, multiplication, division, addition, and subtraction. All right, next example. Next example talks a little bit about modifying the values of variables. And so, as we talked about a little bit earlier, it's always important for us to, we always must declare that variable first and assign it a value before we start trying to modify it. And so in this program, what we're doing is we declare a variable called count, and we say the value of it is 1, and we'll print the value, that value out to the console, and we should get the number 1 when it prints. And then we want to modify the value of that variable. Say we want to add 1 to the value of count. So we say count equals count plus 1. Okay. So now what we're doing is we're upping the value of the current value of count, which we know to be 1, and so it's updating the value of count to the number 2, and so we'll get 2 whenever we print out count. Now there's another way. There isn't a way to do this because this is a little bit wordy. So in Python, you have several examples of how to do this with addition, subtraction, multiplication, and division. But with addition, you can modify the value of count by doing this plus equal sign, and that's just kind of shorthand. And so what we'll get there is, because it's already, we know that it's already the value of 2, it's going to this is telling us to add 1 to the current value of count, so that'll make it 3. So whenever we run this program, we should have on line 1, 1, on this line 2, and print out number 3 for this. So let's run it and see what happens. And sure enough, every time we run and print out the value of count, it has increased 1 each time. All right. Another thing that your book talks about are the type conversions. You can convert floating point values to integer, and so for using the int function. And so let's declare first in this program we can declare a floating point value, variable called value, and say that it is equal to 5.6. And then we want to print it to the console, and we have this int function, and whatever the value of 5.6 is it's going to be cast as an integer. Okay, so it's going to convert that to an integer, and let's see what that looks like when it's run. Okay, and so we just kind of ignore this code for the moment. So what it's done is it's taken 5.6 and evaluated it as an integer, and it gets the value 5, and so it's converted it to a floating point. We can also do this because it's the exact same thing, and we'll run it again, and we still see that it's still the value of 5 because it has converted it integer, and it's a lossy conversion because we have lost that. And we can also round. We can use the round function to round to the nearest integer, and so if we print and use the round function to the variable value, then it will round it to the nearest integer. 5.6 then becomes 6. Now what if value is actually 5.2? Then what's going to happen? Let's do that. We're going to get rid of that and save it and run it. Okay, then because it's closer to the number 5 and not the number 6, it has rounded it down to the number 5. So These are some that you can, these are two functions that you can use, the int function and the round function, to round to the nearest integer. All right, your book goes on and does some other interesting little things, just kind of some advanced types of programming. I would strongly suggest that you kind of look through some of those case studies and make certain that you understand the time function. Make sure that you understand a little bit about the software development process, and look through the compute loan program at the end of the chapter. And if you do these, and they'll be completely ready to do not only your homework, but you'll be ready to move on to the next bit in the class. So again, make certain that you get your homework done and turned in, and hope you have a great week. If you have any questions, as always, please make certain that you contact me. I'm glad to help. Have a great day.